Hi, my name is Amy Kelly, and I'll be teaching the Discrepant event, Dancing Raisins. I'm teaching this to a third grade class of 20 students. The items that you need are a Sprite, 2 clear cups, water, and raisins. This covers the standard 3PS1 matter and its interactions. Number 3, describe and compare the physical properties of matter, including color, text, shape, length, mass, temperature, volume, state, hardness, and flexibility.
So we're going to do an experiment, okay? And we're going to have Sprite and water and raisins. So, does anybody know what density is? What's density?
Density?
You know what that is?
I do.
Can you read it off of here for me?
On that first.
Uh-huh.
I can barely see. I know what it is.
Can you read it now?
I'll probably have to be closer.
You have to be closer. You
I can read it.
It's okay. We're going to let him come closer, okay?
Okay. Density.
Density.
Density is a word we use to describe how much space an object or substance takes up. It's
Volume.
in relation to the amount of matter in that object or substance, its mass. Another way to put it is the density in the amount of mass per unit of volume. If an object is heavy and compact, it has a high density.
Okay, thank you. That's probably really hard to understand, so I'm going to put it maybe in something you guys can understand to go along with this. So when you guys were little, did you use floaties to swim in a pool?
Yes.
Yeah.
I still use
And it helped you float, right? It helped bring you up out of the water, so you couldn't swim, you could still float in the water.
I don't use floaties.
So listen, okay? So when we have those floaties on, if we're like this in the water, we're a certain size in the water, right? And the pool is bigger than us. But when we put floaties on, does it make our arms bigger?
Yes.
So it makes us have more space in the water, right? So that takes up more volume. So the water that has a higher density than you will push you up out of the water because you took part of the water away from you. So you're bigger, you were smaller. When you got bigger, you pushed the water away from you. So it made you buoyant, made you float, okay? So we're going to see what happens with water and with Sprite when we put raisins in it. We're going to see what happens with how dense do you think a raisin is? Do you think a raisin's going to be heavy enough to fall down into the water and the Sprite, or do you think it's just going to sit there? You think so? Okay, so on the first part of your sheets that I gave you, I want you to write what you think is going to happen when we put raisins into the Sprite.
So at first I think it's going to sit there, but then after a while it will sink down.
Do you think it's going to sink after a little bit?
Yeah.
Okay. Go ahead and write that down for me. What do you think it's going to do?
I think it's going to fall down into the bottom.
So you think it's going to sink too?
Yeah.
What do you think, Isabel?
I think it's going to float and sink after.
Okay. What about you? What do you think?
I think it's going to sink into the Sprite.
Okay. Let me ask you this. What's different in Sprite than in water? What do you think? Huh? Not sodium. Think about, look, if I pour water into this cup, okay, you can watch me pour the water, and it's not really doing anything, is it? It's just going in, right?
Yeah.
But what happens when I pour the Sprite in there?
It's going to fizz up.
It's going to fizz. So what's in it that makes it fizz and bubble? What, do you know what it is?
Sugar?
Not sugar. What's causing all the bubbles? Do you know? You forgot?
I have a different.
Do you know, Davis?
Wait, did you say how the fizz goes up?
Yeah, what's in that Sprite that's not in water that causes all the bubbles?
Is it sodium?
It's not sodium. Do you know what it is?
It's like this edible acid. No.
There is probably acid in soda, that's true, but it's not what causes it. Do you know? Not calories. What's in it is it's air. It's carbon dioxide inside those little bubbles.
Oh.
And so that's what makes it fizz and have all those bubbles, okay? So when we're talking about the density, you have to remember in this one, it has air inside of the liquid. So does that change what your thoughts on what might happen? It does?
I said it was.
What do you think now, Kaylee? You still don't know?
I don't know.
What do you
They
think?
don't float.
You think it's going to float? Why do you think it might float?
Because it's light.
Because the bubbles are lighter? And you think that's why those come to the top and fizz up? Because they're lighter than the liquid? Okay,
And the
Let me
bubbles might make the raisins float.
might do it. Let's see. All right, so that next section where you see the glass on your paper, it says what I observed. Okay, so when we do this, I want you to write down what you see, what you notice, okay? So if I put these in water, they sink, right?
Okay,
Okay.
I thought that would help.
Now let's think about the raisin too. What's up with the raisin? Is it shiny and smooth and flat?
No.
What does a raisin have? What does a raisin have?
Wrinkles.
It has
Not
wrinkles.
Flat.
You're right. It has
It's a dry
wrinkles.
grain.
And it's dry, so it's rough, right? Just like dry skin would be rough. A raisin has wrinkles and it's rough. So carbon dioxide bubbles attract to that rough surface and they attach themselves. Okay? So what do you think is going to happen now?
It's gonna float.
Okay, you ready? Can everybody see? You can't in the back. You can stand up, okay?
Oh!
Now wait. Let's see if it goes back down. Oh, they just fell down. And they're coming back up.
It's a never-ending cycle.
Okay, so take a second and write down what you see. What did you guys see happen?
I noticed
You're right. You know?
Can we jump?
You can.
I don't have the
And you can keep looking at it because it'll keep doing it for a few minutes, okay? So if you want to look at it and keep writing notes, you can.
But then probably when it's done, it's probably just gonna sink.
You think they'll finally sink eventually?
No, I think it's gonna.
When you drink a soda, does it stay fizzy?
No.
No. When does it not stay fizzy? Is
When
it
you
fizzy unless you add ice?
Yes.
So if you add another liquid to it, it kind of takes the air out of it?
Yeah. Put ice in it. So it can.
But this doesn't have any ice in it. It's just a soda, so it should keep doing it for a few minutes.
It's like they're dancing.
Yeah, I know what you're talking
We're having
about.
a pool party.
You have a pool party?
Yeah, we're having a pool party.
So those little bubbles are kind of like life jackets.
Oh, yeah, this was on the classes. Oh, I know what was science and social studies. That's one.
Yeah?
All
Alright, did everybody write down what they saw?
Yes. Yeah. But only it's a never-ending life cycle.
Yeah, keep
So I
going.
couldn't see how it's going. I think it's coming back up for air because
You think? Why do you think the bubbles carry it to the top?
because I know
Come on, let's give him a chance, okay?
because the bubble will get to it and go get into it kind of.
Well, they attach onto it. You're right. They attach onto the
I
raisin.
know. I think
Yeah.
I know.
What do you think?
They're lighter than the raisins, causing the raisins to float up and go sit down, float up, sit down.
You're right. He's got it. Okay, so those air bubbles are lighter. Okay, and when they attach to that raisin, they help push it up because they're lighter and don't add any weight to those raisins, but they expand how big they are, right? Just like your floaties on your arm. So if the raisin is here and it puts bubbles around it, it takes up more space and pushes that water away from it, right? Just like floaties do in the water. They make you a little bit bigger, but they don't add any weight to your body. And that air is lighter than the water around you, so it'll help push you up, just like that's helping push the raisins up. Why do you think they go back down? You haven't been called on. Why do you think they go back down?
I think why they go back down is because once they go to the top, and basically the bubbles are probably like forcing it down from the energy.
You think? That's a good thought, but let's see. I'm gonna call you.
But once the bubbles get to the top, they just leave the soda.
You're exactly right. And so
Yeah.
they leave the raisin, right? Because they go out. They pop and go out. So that's why the raisin falls back down, and then what happens?
It goes back to it.
More
and then
bubbles.
it goes back. It pushes the raisins up.
You're exactly right. So if it loses its air, the carbon dioxide goes out of the liquid, out of those bubbles, and then it falls back down. More bubbles are attracted to it and pushes it right back up. So it keeps dancing back up and down, right? All right. You know what this is called? This is a principle called Archimedes' principle. Archimedes' principle. It's saying that when you are in something and you're heavier than what's around you, you're going to sink. But if you add something that doesn't add weight to your whatever it is, your object, and you take up more space but not more weight, it'll push you all the way up. So you become buoyant. Okay? Thank you guys. I really appreciate you guys listening and helping me today. Do you have a question?
Yeah. What if you put the Sprite in the water with it?
If I put the Sprite in the water, it won't mix very well, and the bubbles won't stay because then you're making the liquid go into it, and you're making the whole product change and the mass change. So it won't work. It has to be by itself. Okay? That's why when you put ice in it, it kind of waters down your drink, and eventually it won't have the fizz in it anymore like you started.
It'll just taste like water.
Yeah.
Also, like, I'm looking at the raisins, and some of them don't all go all the way down.
You're right. Some of them aren't, but they still have bubbles on them. If you're up here, you can see there went one. The bubbles are just releasing slower. And that's probably because it's attached to something that it likes. So it takes a little bit longer for them to release. Mm-hmm. It might be.
But
Yes.
why are some just staying at the top?
Because those bubbles that are on it are taking slower time to release because they're attached to something that they like. Okay. All right. Thank you guys. I appreciate it.
Can we go up close?
Sure you
I'm
can.
gonna try this out.
You gonna try it at home?